Good morning, everybody. Today I will discuss sequential circuit. So, first of all, combination. What is the comparison between combination circuit and sequential circuit? So, combination circuit are probably included in every digital system, and majority of real-world system also contain storage component. So, in this diagram, you can see this is the combinator circuit, only one input actually applied, only or multiple input applied, and you can get the output. But sequential circuit, it has combinator circuit as well as some memory device that actually fed it to the input position. So, what will be the combination circuit? So, combination circuit, no any memory feedback absent and stable out. Sequential, it has some memory, feedback present and time dependent output. Okay. So example of combinator circuit, adder, half adder, full adder, multiplexer, decoder, etc. Sequential circuit, flip-flop, example of flip-flop, SRD flip-flop, register counter. Okay. So here some um, block diagram representation of digital circuit, combinational and sequential. Combinational circuit in this way, and sequential circuit output dependent current input and previous state. Okay, and this is the example. So this is the difference, some features actually discussed here. So output dependency, memory, feedback, clock, uh, complexity and speed. So in the combination and sequential circuit, here some present input only, here present input as well as past output. So combination circuit, no any memory device, here some memory device inbuilt, no any feedback path. So here some feedback path, no any not require synchronous, require synchronization, easy to design and relatively harder to design of sequential circuit. Combination circuit always speed is fast and the sequential circuit slower due to the propagation delay. Okay. So synchronous clock sequence circuit. So a synchronous sequential circuit may be used as a flip-flop to store as a many bits of as necessary. The output can come either from the combination circuit or from the flip-flop or both. Okay, flip-flop nothing but a memory device that will be stored the output of the after operation. So here you can see input is applied, first input is applied to the combination circuit, so you can get the output. So when it is sequential, so it has some memory, so that output actually stored in this position, flip-flop. After that, this output will be fed to the again input. So this is the basic block diagram of sequential circuit. That means the output is depend on the present as well as past output. Okay, and at that time some the sequential circuit, uh, it will be depend on the timing clock pulse. So this is the timing diagram of the clock pulse of sequential circuit. Now introduction of flip-flops. Here I discuss the flip-flop have some following properties. Flip-flop has two stable states, hence there are, it is called bias-stable multivariator. Two stable state means high and low. This is the high in digital one, the digital circuit in logic 1. Low means this is the digital logic 0. They can switch between state under the influence of the control signal, clock or enable signal. Okay. Now flip means state, one state, and flop means this is the back to the another state. That means flip-flop. It can store one bit of data, that actually 0 or 1. Okay. Two output are complementary to each other. So here some diagram I show you here. Some input will be, multiple input will be considered inputs, and Q bar. So this is the normal output, and Q bar is the inverted state, or this is the complement of Q. Okay. So this is the two output you can get of the output portion. Now, sequential memory, I already told you that flip-flop is a storing device, that actually memory device that actually stores some data. That means one bit of data actually stored 0 or 1. So, sequential memory family tree, sequential memory element is latch and flip-flop. So, gated latch sometimes is called gated latch, means gated latch, and you can add some clock transmission signal, so at that time you can get the flip-flop. So if difference between latch and flip-flop, so that time you can say that latch, no any clock pulse is required, no, for operation, but this is the flip-flop, it will be operate in the clock signal or gate signal. Okay. Now in this figure I will show you the SR latch with OR gate or gate configuration. So SR-latch circuit, two cross couple NOR gate or two cross couple NAND gate. I will show you later the NAND gate based configuration. So here two inputs are S for set and R for reset. So you can see here this is the R and S in the first NOR gate. This is the R input. One input is R, another input coming from Q bar. This is the output to input. This is the concept of feedback. Okay. And another NOR gate, that actually S is the input, another input coming from the normal output of the NOR gate number 1, that Q will be fed to the gate number 2, NOR gate number 2. Okay. So this configuration is a example of SR latch. Now you can see this also called, this is the active high SR flip-flop. SR latch, sorry, active active high SR latch. So why? You can see this is the truth table of SR latch. So 0 0. So when both the input S and R, both the input will be 0. So that time no changes. So your state at that time you can say that the no change state. Now R value is 0, S value 1. So here some consideration you can consider, this is the, if previous value is 0, so or this is the 1, so it will be always this is the 1. So you can say that this is the set state. When 1 0, so at that time you can get after operation, so it will be 0, so this is state. But when 1 1, so at that time you can say that this is the Q position is 0 and the Q bar position also 0. So it will be not applicable because this is the Q and Q bar complement to each other. So it will be not possible, both the output will be same state. So it will be considered this is the forbidden state, or this is actually forbidden state, or this will be the rest state. Now next SR latch with NAND gate base. Here two NAND gate. This number 1 NAND gate is one input is S and another input coming from the Q bar. Here this is the NAND gate number 2. Second first input actually R and another input coming from the Q. Okay. So here also some truth table. It will be considered when both the input will be 1 1. So at that time you can get this is the no change state. So this is the 1 1, it is no change state. This is the 1 1 state, no change state. But when it will be 0, so at that time you can get the forbidden state. So that will be the problem, or you can say this is the active low. Active low SR flip-flop means 1 1 state, no change state. If any input value actually low, so at that time you can get set or reset value. But 0 0 is called forbidden, or this is the rest state. Now, graphical representation of latch. This is the SR latch. This is the here bubble means this is the not actually connected before this position, and this is the another one. This is the D latch. Now, flip flop. I already said that latch and flip flop. Latch no any clock pulse activation, but this is the flip flop. Activated device will also added some clock pulse. So the latch trigger and transition cause the set to the trigger of trigger the flip flop. So here some positive level, this is the 0 and this is the high, means this is the low and this is the high. So this is the black line, actually consider this is the positive level, and this is the downward direction or downward line is called lower or negative edge in this. This is actually mean of this figure. Now this is the positive edge. Also you can direct it. This is the rising edge position. The direction is called positive edge, and this is the falling edge position. This is the downward direction arrow is considered negative edge response. Now this is the SR flip-flop, or you can consider this is the SR latch with control input. That means clock input actually applied. So you can see this portion, or this is the portion. This is the portion is the SR latch. Okay, this is the S and this is the R position, SR latch, and when you can add some clock pulse, so extra NAND gate you can introduce before this SR latch, and one clock pulse also introduce. So consists of basic SR latch and two additional NAND gate and clock pulse. So this SR clock SR flip flop, you can say this is a clock SR flip flop or SR latch with control input. Now this is the similar operation of the SR latch, but it has some additional clock pulse. When clock pulse in this figure means this is the truth table of the SR latch. It shows that no clock pulse is applied, means this is the cross sign of this clock pulse position. At that time no input S and R position, so you can do not get any input output value, present state and next state position, so no change state. Also when clock pulse is applied and both S and R value is 0, so in this table actually creation 0 0, possible output will be considered. Present state means those value actually stored in this memory position, so we doesn't know it is 0 or 1, so both the cases here consider 0 1, 0 0 0 0 0 0 0 1, the 0 0 case of the SR flip flop, 0 1 case position, the 0 1 1, 0 1, 0 1 0 and 0 1 1, and this is the third case 1 0 0 1 0 1. All possibilities will be considered here, and after operated clock pulse is applied and input will be applied of SR position. So after the changes here, here it will be changes to the present state to next state. This is the present state to next state. So here 0 0, so 0 0, so present state 0, so output also, next state output also 0. When it is 1, so you can get the 1 value. So 0 1, when S value is 0 and R value is 1, so you can see this like 0, no changes. When 0 is output is 0, present output is 0, next state output also not changes. But when it is consider this is the 1, so it will be changes to the 0. So both the cases, both the case will be considered after your next state will be decide the which state it is situated. This is the reset state. Now 1 0 case, it will be changes to the 0 to 1 and 1 to 1, means no changes the 1 to 1, but 0 case 0 to 1 it is changes. So I said that this is the set state. Now 1 1 condition. So again some problem actually arise in SR flip-flop. 0 1 case, we cannot judge this is the present state to next state, means this is the both the input Q and Q bar both will be 0 0 or 1 1. So that time we cannot consider the output because Q and Q bar is the complement to each other. So that is why we are written here. This is the undetermined state or forbidden state. So this is the problem of SR flip-flop. That's why we can build another flip-flop that will be the D flip-flop. I discuss later, but SR flip-flop has some characteristics. This is the truth table or characteristics table, you can say. And after the symbolically represent, this is the symbolically represented, this is the clock, this is the positive edge trigger. But when this is the negative edge trigger, so in this clock position, you can write this is the negative edge. This is the negative clock. Okay. So this is the S and this is the R and this is the Q and this is the Q bar. Okay. So this is the negative edge trigger. Now, now we can see this is the symbolical logic diagram, and also from the truth table you can satisfy the what is the characteristic equation. So 0 0 0 case, so the S value will be 0. So previous case you can see the diagram of from the truth table, you can see this position 0, this position 1, means this is the S bar RQN, the 0 0 1 case, this is the QN plus 1, the next state value is 1. So this is the 0, this is the 0. So here 0, this is the 0 position, this position is 0, and this 1 0 0 case, you can get Qn plus 1 is 1, and Q 0 1 0 1, this case, this is the Qn plus 1 will be 1, and after that these two case, this is the 1 1 1 and 1 1 0 case, this is the don't care condition. So if you are from Kamdam map, you can combine and you can get the equation S plus Q bar Qn. Okay, and also consider S and R multiplication always equal to 0. So that will be the satisfied of the characteristic equation of SR flip-flop. Okay. Now in this position, in this diagram, also I show you the timing diagram of the SR flip-flop. This is the clock pulse applied to this. Clock pulse is applied. Sequential clock pulse applied. So I here some positive edge. This is the position will be positive edge. When S and R value is randomly we are taken here. Now Q will be, what will be the Q? So when clock pulse is high, so at that time S value is 1 and R value is 0. So this is the Q, N value will be 1. So this will be the high and continue of the sorry, next clock pulse. When next clock pulse is applied, second clock pulse is applied, at that time S value is 0, R value is 1. So this is the reset state. So here this is the Q will be goes down and continue 0 to the next clock pulse. When next clock pulse is third clock pulse or next clock pulse is applied, so both the input S and R value will be both are 0. So no change state, memory state or no change state, you can say both will be, you can say. So it will be continue of the next clock pulse, means fourth clock pulse. When fourth clock pulse is applied, so R value is 0, S value is 1. So it will be again set and continue of the next clock pulse. Fifth clock pulse is applied. So fifth clock pulse, R value is 1, S value will be 0. So you cannot judge this is the position, what will be the state of the SR flip-flop. Okay, so here I will show the state diagram. State diagram means here two stable state, 0 and 1. We already state this is the flip-flop is a bistable multivibrator. So that is why your input when changes, so which state it will be situated, so that actually considered as is a state diagram. So Q1 state and this is the Q0 state. So when 0 0 S value, S and R value is 0 0 and 1 0, so he holds the Q1 state, means one set state. When Q say reset value or Q value is 0, reset state, so Q S and R value will be 0 0 and also S and R value. So when S and R value is 0 0 and 0 1, so that will be means that he holds the reset state. And when 1 0, he changed the state, reset state to set state. So 1 0 case, it will be changes the state. So it will be input, and also this is the set state to reset state when input value S and R value is 0 1. So this is the called state diagram of SR flip-flop.